I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. Again, Lord, I thank you for these students. Just pray you help us to use this time wisely, just to prepare for the test upcoming tomorrow, Lord. In your name I pray. Amen. Let's see here. So I'm going to... You guys have any questions while I'm handing these back?
Get my test graded.
Do I have your test graded? No, I do not. Let's see here. I thought about it though. It was close. Almost happened. It was really close. Robert, is Robert over there? Hand that down. You have a question? So he has written like 26 out of 30 or whatever, but if you look at the grade book, he's rescaled these to be 100 out of 100. I will then later, at some point, of course, rescale them to be actual points, but that will not happen until later, as I described in the annoying and lengthy announcement. Let's see here. Jared? Sorry. Yeah, I don't think so. Let's see here. Make them all out of 10 points. So one person's for 100 points, the other person's for 10 points. Let's see here. So you guys have any questions about the material while I'm doing this exciting task? You're fine. Don't all speak up at once. Where's Michael? Usually here. Well, here's some more. Very happy with the speed of the grader here. It's got these back to you guys pretty fast. Yeah. Oh. You want me to ask me a question? You've done questions which are not assigned. You want to ask me questions about that? I mean, you're welcome to. You are back here. I guess I'll just talk about the ones I already have on the board since they're already on the board. I do not post a solution to the practice quiz. That's up to you guys. It's your quiz. Do what you will with it. Come on. Of course, I have a lot posted already, I think, between this semester and the last. Well, come on. Wake up. Hello. Hello. All right, so problem one, I mean, I'll say a few words. A is alternating. This is just the alternating harmonic series, right? B, you can do limit comparison to p equals 1 if you'd like. If you look at the ratio of the given series, the term in the given series to the 1 over k, you get k squared plus 3k to the 4th over k to the 4th plus k cubed plus 1. This has limit 3 as k goes to infinity. Therefore, by limit comparison test, you can get divergence of B. Now, I should say, I noticed on the quiz, a lot of you were not paying attention to the fact that you can only use positive series test for positive series, right? That's one of the sort of systematic errors. I saw a lot of people applying non-relevant tests to an alternating series. Like, it's hard to explain exactly, but you know, there'd be like negative terms in the series, and you'd use the root test, or you'd use an unqualified ratio test or something. I mean, there is a way to use the ratio test on terms of negative series, right? You just test for absolute convergence instead of regular convergence, and then you can use the ratio test on a series that has is non-zero but has negative terms. You can just test for absolute convergence if you want. We do it all the time in the interval of convergence calculation. Let's see here. This one, you can do direct, like basic comparison to geometric series, right? I seem to have erased that, but it's easy to see what 2 to the k over 3 to the k plus k squared is less than or equal to 2 to the k over 3 to the k, right? Which is 2/3 to the k. And so you can argue, you can argue that, oh well, if I was taller. You can argue that, this would converge by geometric series r equal to 2/3, right? So you have a larger series which converges, therefore, by direct comparison or basic comparison. This also converges because it's, after all, a positive term series, right? And then D, you could use ratio test, right? Now, if there is a question like this on the test, and there might be, it's both a pro and a con. I mean, the pro is you could write all kinds of crazy nonsense, and if you say converge where it converges, and if you say diverge where it diverges, I'm going to count it 100% right. On the other hand, if you say all kinds of really cognizant, well-argued things and come out to the wrong answer, you get no credit. So it is what it is. You know, this kind of question, it works for you and against you. Of course, I'll have other questions probably where you're actually supposed to show your work. Like what? Problem 4, for example. You know, here would be the work. First of all, f of x is equal to minus 1 to the k over k times 2x minus 3 to the k. This is not a power series, right? Because a power series is a coefficient times the factor x minus x naught to the k, or x minus c to the k. It has to be written in this format, otherwise it's not a power series. This is not a power series, technically speaking. But this is. And because I have written, I have identified the coefficient as this piece right here, right? So anyway, excuse me. So if I call this whole thing a sub k, then I can apply the ratio test. You do that, you simplify it, you get twice x minus 3/2. Therefore, the series of the absolute value of a sub k converges. In fact, if we have the condition 2 times the absolute value of x minus 3/2 less than 1, right? And so you can divide by half, and that shows you the interval of convergence at least includes 3/2 plus or minus a half. In other words, 1 to 2 is the so-called open interval of convergence. It's necessarily part of the real numbers where this series converges. It remains to be seen whether 1 or 2 actually is in the domain of this power series. And to see that, you actually just have to plug it in and see what happens, right? You plug in 1, into this thing, you get the harmonic series, so 1's excluded. You plug in 2, in fact, you get the alternating harmonic series, so it's included by the alternating series test. And so the interval of convergence here is 1 not included to 2 included. That's the IOC. What's the radius in this case? What's the radius of convergence, the ROC? 1/2, yeah. So anyway, that's what I have on the board. So you guys have questions?
Where do we find the previous tests that you were talking about?
On the website.
Course content folder, or is that
No, they're on the super math. So like for example, here's one. This is from 2009. This is test 3. Math hasn't changed.
can you do that
Yeah, we'll get back to that. But I mean, at the moment, it's www.supermath.info/math132_test3_so9.pdf. You can use that directly. Let's see if I can make it bigger. Yeah, well, it doesn't make the doesn't make the address bigger, but I will show you where it came from here shortly. Let's just talk about the test for a minute, though, before I do that. So here's another one where you're asked to find the interval of convergence and radius of convergence. In this particular case, you don't need to check endpoints, right? Because this is just straight up geometric. And so if it's a geometric series, by the geometric series result, which you should be able to prove, right? That's pretty much the only proof I've asked you to be able to prove. I mean, formal proof, I guess. I mean, I don't ask you to be able to prove the ratio test or the root test or the direct comparison test or the limit comparison test or the, what else test? I don't know, integral test or the alternating series test or the other one I'm forgetting. But I want you to be able to use those, right? But prove them? No. On the other hand, geometric series, I would like you to be able to prove that one. Anyway, so here, this is geometric if you look at it. And so because of that, I already know that the endpoints are lost. They're lost to us. So the interval of convergence is just what it is there. So that's kind of nice. If it's geometric, you don't have to check endpoints, right? That's a convenience. That saves you some time. Here's a question about possible intervals of convergence. And I think the answer here is mostly right, but slightly wrong. So I've got a function 1 over x minus 2. What's the largest interval of convergence possible for a power series representation of f of x centered at 2.5? The point here is 2 is not in the domain of f, right? There's division by 0 there. So that means I can't get past 2. That's no man's land, right? There's this natural barrier at 2. I can't get past there, which means I can get at most 0.5 away from my center. So the maximal radius of convergence here, without working out the details, is 1/2. But here's the thing. Logically speaking, it could be that 3 is included. I don't know, without working out details. It may or may not be that this is actually true. Logically speaking, I could make this included, thinking about it. Without actually working out the details, I don't know. To work out the details, I'd actually have to do what? Could we work out the details? Let's do it. What's the power series for this centered at 2.5? I may regret this. I already regret using this marker. Let's see here. I want x minus 2.5, right? So what did I just do? I subtracted 2.5 that wasn't there, right? So I need to do what? Plus 0.5. And I want that 0.5 to become 1 so that I can do the, oh well. So this is multiply the top and the bottom by 2. Right? Multiplying the top and the bottom by 2 over 2. 2 times 0.5 is just 1. Now I have at least the geometric series, so I can do it. This is 2 times the sum. I'm going to use n because I'm tired of k. N equals 0 to infinity, 2 to the n, x minus 2.5 to the n. And there you have it. The power series representation centered at 2.5 is just this. So now you can tell me, was I right? What's the interval of convergence? This is for what? How do I know the endpoint's excluded? It's geometric, right? So the fact that 2 is lost to us means 3 is also lost to us. That's the structure of the geometric series. Yep.
Since it doesn't ask to specify it and it wants the most maximum privacy, should we put division because it doesn't know?
Yeah, that would be the, well, I mean, see, this one is ambiguous in that regard because I might expected you to do this here if the wording was slightly different. I actually intended not to do this here when I wrote the problem. Actually, I don't remember. It's been a while. But yeah, I mean, this one's a little bit ambiguous in that regard. It's not a great. If you find yourself wondering about that kind of question, you should, of course, approach me and ask. Yeah. Oop. Now, this one here, this one's just like the one that's on the quiz. It's not geometric. You just got to apply the ratio test and check the endpoints. It is what it is, all right? But again, it's harmonic and alternating. It seems like a lot of the examples that I come up with there end up being like alternating or harmonic on the endpoints. It's quirky. This one's the one you're looking for, though. So this one is abstract in the sense that you're given these coefficients c sub n such that the series diverges at 3, right? Is it possible for it to converge at 2? Well, yes. I mean, once you know it diverges at 3, if the center's at 1, that means that anything within 2 units, it's possible that it converges. Anything beyond 2 units away from the center has to diverge by the divergence theorem, right? If you diverge at 1 point, which is from the center of the power series, distance 2, then anything beyond distance 2 from the center to the right or to the left must also diverge. That's the game of the play here. So, you know, so that's kind of like the only way you can reason this problem, right? Because the c sub n's are not given. Whereas with this other one we were talking about, there's an actual formula, so you could actually calculate in principle. And, yeah. And geometric series, here's one where you differentiate, apply the geometric series, and then integrate to get back. By the way, once you differentiate and integrate the interval of convergence, if you wanted to investigate it, you'd have to investigate it. In the process of differentiating, sometimes we lose endpoints. In the process of integrating, sometimes we add endpoints. So if you use geometric series paired with integration and differentiation, you may lose or gain endpoints, all right? It's only when it's a direct application of geometric series do we know the interval of convergence just from the application of the geometric series. Yes, sir?
Real quick, for tangent, inverse tangent, dx over a squared plus x squared is the derivative of inverse tangent, not tangent.
Yeah, derivative inverse tangent of x would be 1 over 1 plus x squared. Now here there's a chain rule going on, right? It's like 1 over 1 plus x cubed squared, which is x to the 6th, and then derivative of that is 3x squared. So it's like chain rule. Here's an integrate, change it to the power series and integrate. All right, I think that's a nice problem. So here, find the first 3 terms. Well, here's a good reason to know the binomial series, right? If you know the binomial series, and you are allowed to know the binomial series, that is not something I forbid, right? You could memorize the binomial series. If you did that, then you wouldn't be, oh my goodness, what if you applied Taylor's theorem directly to this problem? Yeah, you're dead is a good way of looking at it. Yes, you'd be wasting mounds of time, because this you should just look at as x to the 5th times binomial series, right? And then it's pretty simple. So all you really need for the binomial series is the first 3 terms for the most part. If I'm going to ask about a question, I usually just ask for the first 3, maybe 4 terms at the most, usually, if it's this kind of problem. Of course, for this kind of problem, I might ask for the complete series solution, right? All right. Or as I said in the quiz, give your answer using summation notation, right? That's another way of saying, give me the complete series solution, please. All right, let's go back to, there's a few more questions here. I'll let you look at these. We've done these problems, like everything in here we've done.
Where is this? Is this anywhere?
Yep. Here's a better, by the way, the error question on the quiz is unfortunate. You have to go all the way out to like the 7th or 8th term in that. That was I didn't mean for it to be that nasty. It was an accident. I could easily fix that problem. Instead of saying integral of like e to the minus 3x squared, if I just instead made it x squared over 3, it wouldn't have been so bad. If the 3 was working for us rather than against us, that problem wouldn't have been too nasty. This is a better example of the kind of thing I typically do on a test, something that's not numerically so hideous. It's really just testing on do you understand the theorem, right? So if I say that that's equal to 1/5 plus an error term, if you just integrate term by term, you'll find out that 1/5 is the first term in the series approximation of the integral. And so the next thing, it's an alternating series, so the next thing captures the error, right? It's within 1/14. The answer is 1/5. That's the alternating series estimation theorem. That's also how you do the one in the quiz. It's just, it's ugly. Excuse me. And I do want you to know Taylor's theorem. I don't want you to always use it though, right? If you look at the solutions to my old test, you'll see I use Taylor's theorem sparingly. The majority of what I do is to combine results that we already know. Maclaurin series for exponential, sine, cosine, right? The geometric series technique, these are the big ideas. Taylor's theorem is important though, right? Because it is how we actually do those other problems, like how do you calculate the 50th derivative or something, right? It's at the base of everything we're doing. But the actual implementation of Taylor's theorem for a specific example is usually pretty tedious. Take-home bonus. Ooh, exciting. I must have had more time in this semester. Let's see here. All right, so to answer your question, Mr. An, we are now back to the Calculus 2 webpage and test solutions from spring 2009. That was test 3. Now test 4, if you clicked on that, wouldn't have been relevant, right? Because that's what we're doing next. No. You can get a piece of paper out though, and you can like put it over the solution, like cut it and paste it, like print it twice, and then like get a glue stick, and then like, I don't know. It's my low-tech solution for your problem. Yes? Yeah, and it doesn't matter. You know, like I said, for this semester, you should look at what we've done in here. Think about what we've talked about in lecture, right? What we've done in the homework. Think about that. That's how we should think about our test review. I mean, I might have have I posted one down here somewhere? Maybe. I don't know. I mean, this is kind of that. There's some study helps down here. Now, this book used M instead of K, so it'd be the nth term test. You know, Um, so, and you notice that the ratio test uses the absolute value of a sub n plus 1 over a sub n. In other textbooks, the ratio test has an absolute value slapped on top of it relative to our text because they always just test for absolute convergence. I might have a, again, I could find, I might be able to find you like an old review or something, but I don't think it's helpful because it might be misleading because it's from another semester. That's why I don't advertise those. If it's helpful, it's good, but you have to, I mean, you have to use it with understanding that this is this semester and what we've done in here is more relevant than what I say on there. And so that's a little bit subtle, and that makes me nervous, and that's why I don't tell students about it. I think you'll be fine, but what else is there? It's probably in here somewhere. Goodness gracious. I don't know, if you look in this chart here, you'll find this homework might be helpful. Like here's Taylor series homework. Find the Maclaurin series, Taylor series, binomial series, tons of examples if you want more examples, right? Anyway. Oh, so on the quiz, let me get back to our quiz. I forgot to, sorry about this. This is quiz 6. Obviously. Excuse me. Um, 11. I don't want you to find the, this is not clear. I meant for you just to find the first 3 terms or 4 terms or something like that, all right? I don't want you to find the whole Maclaurin series. That's, no, not what I intended. Okay. All right, well, you guys have any questions? Yep.
Number 5.
Mm-hmm. What about?
So is the interval of x like the second one is the negative? It looks like it's the negative of x minus 3. Like it would be negative x minus 3 to the k. So what would that do to the interval?
Well, you can just study it directly, right? Like, so k equals 0 to infinity, right? You got yourself, what is it, ck? X minus 3 to the k. Right, this is what, f of x? Or no, g of x? G of x. All right, so if you call this thing, let's call this thing a sub k as I'm wont to do. So if you look at the quotient of a sub k plus 1 over a sub k, what is that? Well, that's, you know, c sub k plus 1 over c sub k. F's the value, right? F's the value of x minus 3 to the k. Now this goes to L, right? Which is less than 1 for what? We know the ratio test applies, and it gives us absolute convergence on the open interval of convergence, right? So that means that this quotient has to go to limit L less than 1, provided x is where? Between 1 and 5, right? X element 1 to 5. But if you look at it, h of x, right? What is that? You can rewrite it as some minus 1 to the k, right? ck, x minus 3 to the k, right? And I can call this thing b sub k. And if you look at the quotient of b sub k plus 1 over b sub k, what do you got? Well, the minus 1 to the k is gone, right? Look at it. You got the same ratio, right? So you know that goes to L less than 1 for x an element of 1 to 5. I mean, there are various other ways of arguing this. You could also argue by substitution. Yep.
X meant 3 without a power k. It's a k plus 1.
Oh, yes, I'm sorry. I mean, Exactly. We're dividing x to the k plus 1 divided by x plus k. We should just have an x minus 3. Thank you. Yes, yes, yes. I've already canceled out the k plus 1 and the k. Thank you. Thank you. Very good. Yes, sir.
Can you do on the quiz?
Yeah. Well, yeah, I just need to finish this. So they have the same open interval of convergence, right? And then if you just look at the endpoints, g of 1 is equal to h of 5, and g of 5 is equal to h of 1, right? So the convergence and divergence is flipped from one to the other. You could also solve this just by substitution, right? You could just directly solve it by substitution. That would probably be even better. You said number 8?
Yeah.
Yeah. What about? Is that? I already took care of that by pulling that out. So like it's minus 1 times, yeah. Oh, okay, so you're supposed to find the hundredth derivative at 0 of x cubed. So you have x cubed e to the x plus cosine x. All right. So this will be the sum. N equals 0 to infinity, divided 1 over n factorial, x to the n plus 3, plus the sum, I'll use a different letter, j equals 0 to infinity, minus 1 to the j, divided by 2j factorial, x to the 2j, right? On the other hand, this is equal to what? The sum, let's say L equals 0 to infinity of the Lth derivative at 0 over L factorial times x minus 0, right? To the L. This is Taylor's theorem, right? So if I want to calculate, oh, come on, the 100th derivative, if I want to calculate the 100th derivative, what do I look for? So I want to compare, yeah, x to the 100 coefficients, right? Let's see here. So the one way I can get 100 from these is when I have n equals to 97. So I have 1 over 97 factorial. The other way I can get 100 is when j is equal to 50. So I have plus 1 over 100 factorial. And that will be equal to the 100th derivative at 0 divided by 100 factorial. So you multiply by 100 factorial, and you have that the 100th derivative at 0 is simply 1 plus 100 factorial divided by 97 factorial, which is, as you were just saying, is 1 plus 100 times 99 times 98. Yep, there you go. So basically the point here is to use known Maclaurin expansions to come up with manageable expressions for the whole series. Now, this would not be, this is a good solution to calculate the 100th derivative. If I also asked you to find the Maclaurin series for f of x, we're not done. Because you'd actually need to, I would want you to add the parts which you can add and, and leave the other part alone. Like, so I can peel off all the even terms in here, Of course, I could be lazier. Another way to do that would be just to go, well, that's x cubed times cos x plus sin x, right? Plus cosine x. And so the even terms are exactly going to be the x cubed sin x plus cosine x terms. And then I have plus x cubed sin x, x cubed cos x. Those are my odd terms. So this will naturally add, and this will naturally stay separate. And when you look at the Maclaurin series for those, you'll get the power series for the whole thing. So otherwise, you have to kind of like split off the even terms and the odd terms in the exponential series as to get the power series representation for f of x. Yep. So this n equals to 97 gives me x to the 100 here, right? Then this one, I need 2j equals to 100, which is j equals to 50, which is why it's plus. Is there any other way you can get x to the 100 from those series expansions? Yep.
For the first fraction, y or factorial, why did you use the variable you need to get to 100, but the second one you just use 100? It's like 1 over 97 factorial, but why is it not 1 over 50 factorial?
Because the 2j factorial is in the power series expansion for cosine. Because you have minus 1 to the j, but you've got 2j factorial downstairs. They don't match. There's always this doubling. It's the same issue with like sine series. Minus 1 to the j doesn't match the 2j plus 1 factorial downstairs either. Yep.
There's x cubed to the x plus sine of x, then the sine of x, like the Maclaurin expansion, which is 0 there.
Right, yes. In fact, if we had added sine x, it wouldn't have changed the 100th derivative at all. The 100th derivative of sine x is 0 at 0. And we would have just had 98 times 99 times 100 as our answer. Yeah. Yep.
So from the 2j factorial one, if you just had j factorial, you could put 50 factorial as a denominator.
If I just had j factorial, if I just had j factorial, that would have been 50 factorial downstairs, and the derivative would have been huge. I mean, truly immense. Yeah.
I'm not trying to beat that horse, but if you get j factorial in the denominator, you're looking for the 100th derivative, so you just have 100 factorial.
He's talking about hypothetically, imagine you have a different series where you have j factorial rather than 2j factorial downstairs. So you will not agree because you're thinking about the cosine series. So yeah.
I have a question about 9. I can see what it's asking for.
Well, the intent of number 9 was to ask you a question that is like the homework 10 problems. Let me show you that one. So here's the problem with number 9 is like in order to get the oh, wait a minute. Number 9? Hold on a second. I think I'm starting to talk about a different one. Before I chase this rabbit, just a second. Which one was number 9? Oh, number 9, there's a typo. Thank you. This is supposed to be plus 1. Otherwise, it doesn't make sense. Right here, plus 1. So the idea there, once I put plus 1, I bet it makes sense to you. So if I put plus 1, k equals 1 to infinity, minus 1 to the k plus 1 over k cubed minus 7/8. Well, let's just write this to start with. Minus 1 plus 1, well, that's 1 minus 1 over 8. And then what? Plus 1 over 27 minus 1 over 64 and so forth. So it's an alternating series, right? So if you look at the absolute value of the series, the p equals, the alternated p equals 3 series here, k equals 1 to infinity, minus 1 to the k plus 3, k plus 1, sorry, divided by k cubed. I'm missing the plus 1 here, my bad. I have a really hard time answering this question without that plus 1. If you're also stuck, understandable. Sorry about that. So this, though, I hope it makes sense once I do this, though. You can tell me this is less than what? Right, because this is the first two terms, right? So that's less than, you just choose 1. Yes, Mr. On, you can in fact just choose 1. But then you must explain to me why that's true. Yeah, but why would the difference between that series and 7/8 be less than 1?
Group the next two together and it's less than.
Ah, you're right. It's always less than the first term. All right, your existence is forcing me to write this in a more clever way. Find the smallest epsilon. Yes, I'll have to say find the smallest epsilon for which this is true. It's not much more writing for me, smallest epsilon, and that way I can grade it more interestingly.
If it's smallest epsilon though, would we then take it 27 minus 1 over and then do a few more terms? What's wrong with that?
No, I mean, and I would say, now your existence is forcing me to say something like the smallest epsilon, find the smallest epsilon for which you can conclude this is, using a theorem which we've covered in this course. And then the theorem, of course, would be the alternating series estimation theorem, right? You're, of course, right that that's still a worst case scenario, right? So there might, in principle, be a smaller epsilon. Fair enough. Not the point. You guys, you're the worst. Actually, this is great. I'm very rarely challenged in this way. I've heard of instructors at other institutions, like the students will try to stump them with hard integrals and stuff. Like, it just never happens. I don't know. Nobody ever tries to lay down the gauntlet for me and say, haha, you can't do that. It just doesn't happen. I'm sure you could stump me. I'm not saying you need to go try that now. Now that I've told you about this, it's ruined it. It's kind of like bonus points that you ask for. They just evaporate. There's a student in linear who keeps killing his own bonus points by asking if that was worth a bonus point. And I always respond, it would have been, except that you asked about it. There's some ambiguities here. For example, my son Isaac was praying. His prayer would go like this. God, please help me not to talk about the Lego set that I wanted. Please help me not ask about this Lego set today. Please give me the strength not to ask about it. And it's like, he was not conniving. He's a 4-year-old, all right? It was a genuine prayer. But at the same time, it's very meta. It's
He doesn't realize he's being
yes. That's the question, is does he realize? I mean, you can't tell him not to pray, right? I mean, sorry, you got a question, Luca? Yes, and that one I think you can go just maybe 3 terms into it. Eventually you get to something that's smaller than 0.1. And that one actually is just that was the one I was going to look at when Daniel asked about that a minute ago. It really is like this one, number 32. I mean, it's that kind of problem.
So you just give us a within.
Yeah.
So we'll go to the top bottom.
I thought I said within 0.1.
We're still talking about bottom 9.
I mean, in the quiz, I think okay, fine, the point, yeah, problem 9 was, I'm talking about problem 10, though. There's an error, 0.1, yeah, 0.01. Yeah, problem 9 is asked in kind of a sideways way. But it's not impossible. Except that it is because I made a typo. Yeah. Well, see you tomorrow for your beloved class participation.